So good evening, everybody. A very, very warm welcome on a especially stormy night. You couldn't have scripted this to have an extreme event on the same night you're having a lecture about climate change. So, but it's wonderful to see so many people here, and I recognise many people from who are associated with the James Hutton Institute and others, so thank you for coming. I'm Colin Campbell, Chief Executive of the James Hutton Institute, and we're an organisation who's named after one of Scotland's most famous and brilliant scientists, James Hutton, whose work in the 18th century describing the inestimable age of the Earth changed global thinking forever. That's a fairly high ambition to try and reach, but we aim to do that tonight. The words of US Special Presidential Envoy for Climate, Senator John Kerry, came to mind recently when he visited Edinburgh and he went to the Scottish Global Dialogues meeting. And these came to me because they seem equally appropriate for this event. So he said, "It is particularly appropriate to be here in Scotland, where, less than 300 years ago, from Hutton to Hume, groundbreaking thinking contributed to the Enlightenment." He actually went on to propose that Hutton's work on the theory of the Earth, the theory of rain, and other work may well have made Hutton the world's first climate scientist. So it's very fitting to have Johan here as one of the world's foremost climate scientists to give this lecture today. Now, the TB Macaulay Lecture is actually one of the longest running science lectures open to the public that aims to connect scientific evidence with civic society on the big issues affecting our land and people. And it's really designed to connect science and those who influence and make decisions on policy. And it's one of the reasons we come to Edinburgh. Now, Thomas Bassett Macaulay first came to prominence as the president of the Sun Life Assurance Company in Canada. And as a son of Scotland, he made several benefactions to institutions in his ancestral home in Scotland, and particularly on the Isle of Lewis, all aimed at improving land. TB Macaulay believed that science could make a difference to the management of land, and he proved this in his own work and his own life, and he also backed science when he helped to establish the forerunner of the James Hutton Institute, the Macaulay Institute. The Macaulay Development Trust continue this good work today, and they fund important work at the Institute, some of which is on display today, and I hope you've had an opportunity to see that at the exhibits. The Trust continue this good work today, and we are very, very grateful for all the continued partnership working with Macaulay Development Trust, and thank the trustees for all their support and for this evening's lecture. Now, the attendance tonight is over 500 people, and I think this has confirmed the status of the lecture as possibly the largest event of its type in the UK. Thank you very much for coming. Now, we like audience interaction, and in fact, you can start submitting questions any time now using Slido and the QR code which is on your seat. Before I welcome our first speaker, I should point out that there is no fire drill planned, so if you hear a spoken alarm, please do proceed promptly to the fire exits where the stewards will direct you to safety. As I said, the TB Mac, as I like to call it, is about bringing science to policy, and vice versa. And at this point, we were due to introduce Miss Mary McCallan, the Cabinet Secretary for Transport, Net Zero and Just Transition. Unfortunately, due to Storm Babbitt and severe flood warnings issued, the Cabinet Secretary must now attend an emergency meeting and cannot be with us in person. Fortunately, we have here Professor Matt Williams, Chief Scientific Advisor for the Scottish Government for Environment, Natural Resources and Agriculture, and he's agreed to deliver her words for us. So thank you very much, Matt, and I invite you to the stage.
Well, good evening, everybody. I'd just like to thank Professor Campbell and the Macaulay Development Trust for inviting us and bringing us all together here today for the 44th TB Macaulay Lecture. The Macaulay Lecture is instrumental, as we've heard, in bringing people together from a huge range of backgrounds to stimulate much-needed dialogue about environmental issues. And the Hutton Institute is making a significant contribution to Scotland's understanding and the world's understanding of key global issues around food, energy, and environmental security. So I'm really delighted that we'll have the opportunity to hear from Professor Rockström tonight. And Professor Rockström is a pioneer of the planetary boundaries framework. And his work has been instrumental in helping us understand the state of the planet's health and has influenced government policy around the world. In Scotland, it's played a key role in informing Scotland's environment strategy, which is the framework for all our environment and climate policies. Sadly, the findings of recent planetary boundaries assessment present concerning reading, with 6 of the 9 planetary boundaries now broken because of human activity. This gives us all cause for concern, but it's also a call for action and a stark warning of why we must not water down our commitments to tackle the climate change and nature loss crises. It also demonstrates that addressing these crises will require a global effort. No nation has all the answers or the means to respond on their own. Only by working together can we meet the need and urgency of the task that lies ahead, and the Scottish Government is determined to play its part. We are committed to addressing the climate crisis and have some of the most ambitious targets anywhere in the world. And we have made good progress. Between 1990 and 2021, our emissions halved while the economy grew by 55%, illustrating that the right kind of economic activity can support a reduction in emissions. But this effort does not stop, and we are only halfway on our journey to net zero. And we know the hardest part lies ahead of us, with emissions needing to halve again by 2030. Our forthcoming draft climate change plan will take bold action to continue to drive down emissions while maximising opportunities for the economy, job creation, and health. But we know that the impacts of climate change are no longer a far-off threat. It is a crisis that, as we can see, is here and now. We've all witnessed the horror of extreme climate events that are devastating communities and livelihoods around the world. It's therefore vital that we take steps to prepare our communities and businesses to become more resilient to the consequences of climate change. Our current plan for adapting to climate change in Scotland includes more than 170 policies and proposals to build resilience. This plan will be updated next year alongside developing Scotland's first strategy for flood resilience. Tackling the twin crises also means protecting our natural environment by halting biodiversity loss. The climate and nature crises are inextricably linked. Restoring nature will reduce carbon emissions, and tackling the climate crisis is essential if we are to protect our natural environment. Scotland's new biodiversity strategy sets out our ambition to halt nature loss by 2030 and make significant progress to restoring nature by 2045. We are also investing in nature at scale, with £65 million in the Nature Restoration Fund and a £250 million peatland restoration scheme. But government cannot do this alone, so we are creating a new investment-ready nature fund that will help mobilise private finance. If managed well, this change will bring us huge benefits, a sustainable, healthier environment, and new sources of economic prosperity. And finally, we must ensure that our transition to net zero and thriving nature is fair and just for all our people. Again, Scotland is taking a leading role. We're continuing to champion international climate justice, pushing for bold action across the world and advocating for the human rights of those most impacted by climate-related disasters. We have developed the world's first national just transition planning framework, which includes plans for key sectors such as energy, transport, land use, and agriculture. We are committed to co-designing these plans. They'll be informed by businesses, communities, and workers across Scotland, and by those who are most impacted, including those who have experience of discrimination, poverty, and wider inequalities. I thank you again for this opportunity to join this event, and I will hand back now to Fran van Dijk, Chair of the Macaulay Development Trust, who will introduce Professor Rockström. Thank you.
Thanks very much, Matt. I'm Fran van Dijk, and I'm the chair of the Macaulay Development Trust. And it is my great pleasure to welcome you all here today. What a huge audience. We've never had a bigger one, so thank you all for coming, especially with the storm on its way. I wanted to also say how grateful I am for the cooperation and support of all trustees from the Macaulay Development Trust. Without their support, this wouldn't be possible. They give their time, their energy, and their amazing advice to make sure events like this come off tip-top, together with the James Hutton Institute, which has put so much into pulling this off and making it such a success. I would like to say a little bit about the research that we like to fund at the Macaulay Development Trust. So we are committed to supporting communities to develop sustainable, economic and socially equitable development in their own communities for their own benefit, and particularly in rural areas. But our investment in science goes much deeper than that, and we work very closely with the James Hutton Institute on a wide range of projects, which, as Colin's already said, some of which are available downstairs. But just to give you some examples, we are, for instance, looking at the role that hydrogen might have in rural farms. We're also looking at cultural issues, perhaps where there are disagreements with two different parties, perhaps from shooting estates or animal rights activists. We are supporting research into cooling rivers so that we can attract back our iconic salmon species. And on top of all of that, we are supporting a centre in Aberdeen where the exchange of excellent science can be encouraged for future generations to benefit from the accelerated research that we're going to be doing now. And there's much more to come. So talking of forward-thinking science, I'm incredibly proud to introduce Johan Rockström. He hardly needs introducing. He's a globally recognized scientist in the field of science and sustainability. He is the director of the Potsdam Institute, Climate Impact Research Institute, and also professor of the Earth Systems Science at Potsdam University. He led, as has already been mentioned, the development of the Planetary Boundaries framework, which will be familiar to many of you and which is very, very widely used and recognized. He's a water expert and has written over 150 research papers. Please join me in welcoming Johan to the stage for the 44th Macaulay Lecture.
Thank you, Fran, and it's a great honor to be here with you. What I want to do over the next 40 minutes is to give you a scientific update of the state of our planet, but also focus on what are the transition pathways for a safe landing for humanity within the safe operating space of planetary boundaries. But to come to that, I have to start basically where Matt began and where Colin began as well, of the turbulence that we're facing right as we speak. The reminder that we are already today starting to see the evidence and impacts of hitting the ceiling of the biophysical systems that regulate the stability of the Earth system, and that the Earth system is starting to send invoices back, really major invoices back, hitting us as we speak today. Now, therefore, any lecture on the state of the planet, our future as civilizations on planet Earth, must start here. I would argue scientifically that this is probably the most important message from the earth sciences, at least over the past 30 years, that we have unequivocal evidence that we've now transitioned into a whole new geological epoch. We are, Greek for humans, anthros, Anthropocene is the new geological epoch. We are the dominating force of change on planet Earth. The scale and the impacts and the interconnectedness means that we're no longer a small world on a big planet with redundant capacity for unsustainable exploitation of resources. Oh no, we're now the big world on a very small planet where we have filled up the whole space. We've reached a saturation point. So we should not be surprised that we're really starting to see nonlinear dynamics in the response to additional human pressures on Earth. Therefore, when we now coming to the end of 2023, the third super El Nino year in only 25 years. I would argue that one of the real surprises scientifically, apart from all the human impacts of record heat events, for example, shown on this chart, the real surprise is that it's occurring simultaneously across the entire planet. We see plus 50 degrees Celsius shock waves in Arizona, for example, over 4 weeks' time, which has never been recorded ever before, but we see it across all the continents. And this is unprecedented, but it's also something that we're seeing in the data. You've certainly seen the data in media. This is the NOAA charts of the unprecedented, completely off the charts observations of surface temperatures in the ocean. So you see the variability range, a wide variability range over the past 50 years, and then suddenly we get 2-3 standard deviations outside of this range currently occurring as we speak. And we cannot explain it. It's not represented in the climate models, it's not represented in the IPCC research work, it's not yet possible for us to have a full understanding of what is happening in the complex self-regulating Earth system. Now, we do know, though, that we over the past 70 years have gone from the blue stability towards the red charts in terms of global temperature rise. And we also know that this has led to the current situation. We are at 1.2 degrees Celsius of global mean surface temperature rise. Now, that sounds like a small number, and it's generally not understood fully. I always want to remind that I think it's better to explain it as being what it is, the warmest temperature on Earth since we left the last ice age 20,000 years ago. Actually, the IPCC, the Intergovernmental Panel on Climate Change, concludes even more forcefully, actually. It's the warmest temperature on Earth over the past 100,000 years. You could put it even more directly that over the past 10,000 years, we've never had warmer temperatures than 0.5 degrees Celsius. So we are already 2 magnitudes outside of the warmest temperature on Earth since we left the last ice age. And in Europe, we have a twice as fast warming, and in the Arctic, it's 3 times faster. This is well understood as the Arctic amplification based on the fact that the larger share of the land area on planet Earth is in the northern hemisphere, and that the albedo in the surface of ice is changing so fast. And the recorded evidence of this, as you know, comes from many independent sources of observations today. So any effort of trying to misinform us about this hockey stick is simply not founded in the observations we have. But this curve is also particularly important as we meet today in 2023, because as I mentioned earlier, we've had 3 super El Nino events. And you see what happens when we have a natural ocean dynamic, when the West Pacific, just west of Peru, releases heat from the surface ocean to the atmosphere. You have a natural extreme year of rising temperatures, floods and droughts, but now we can also, with science and the great weather attribution research that, amongst others, Edinburgh University is working on, prove that these are reinforced by us. And that we have the warmest temperature on Earth so far is 2016, but with a 95+ probability, 2023 will be the warmest temperature on Earth. We cannot exclude over the next 1-2 years even to touch 1.5 degrees Celsius. Not that we crash through it and stay there, but that we may be touching it. This is something that we have to bear in mind, that also explains why we're starting to see larger impacts across the world. The 2022 bill was in the order of $350 billion. What the 2023 bill will be for all the extreme events we're experiencing is unclear, but very likely going to be exceeding that number. So what are we then facing in terms of the journey ahead, which is the entry point to the planetary boundary science? Well, the IPCC is clear here, and this is a summary, which is actually not the latest updated summary, but it's basically building on the AR5 and the AR6, which shows that we need to decarbonize the global energy system. That's the gray part here. The remaining global carbon budget, which was in the AR6, the 6th assessment of the IPCC, estimated at 400 to 500 billion tons of carbon dioxide, has now been slashed down to only 250 gigatons in the latest paper by Forster et al. The slicing is actually because we just continue burning fossil fuels. We haven't bent the curve yet. and the latest update in the science. Now, 250 is a very small number because we emit 40 every year. So 250 divided by 40, it gives us 6-7 years in the fossil fuel-driven world economy if we continue burning as today. But even that is not enough to have any chance of a safe landing to hold the 1.5 degrees Celsius limit, because the IPCC scenarios that takes us to a safe landing are very clear. We also need to transform the brown wedge, which is the food system, the single largest emitter of greenhouse gases in sector-wise, 25% of emissions, need to transition into becoming the orange net sink. This is a massive transition of the global food system. Actually, I would argue it's nothing less than an agricultural revolution, from roughly plus 10 to minus 10 billion tons of carbon dioxide in only one generation. But not only that is enough. To hold 1.5, we also need to keep the green and the blue sinks of carbon intact. The green one is all the intact nature on land, all the forests, grasslands, peatlands, meadows, wetlands. The blue part is a stable ocean, which we see the signs this year of potential instability. If we do all of that, plus the yellow part, which is scaling negative emission technologies, all forms of carbon dioxide removal, direct air capture, then we have a chance, a 50% chance of holding 1.5. So dear friends, what tends to be forgotten is that we're middle of a climate crisis, and the only way to have a safe landing, to hold the 1.5 degrees Celsius, is a global sustainability transformation. Phasing out coal, oil, and gas is actually, and I know that this comes across often as a provocative statement, but that's the easy part of the challenge. That's the easy part of the challenge. We need to transform the food system, keep nature intact, and scale negative emission technologies in an unprecedented way. All of this has to occur simultaneously to have a safe landing. That's where we are at. And this requires, which I will be kind of arguing in the continued part of this talk, a planetary boundary approach, because we have to have the checks and balances across all the systems of the planet, even if we only care about holding 1.5 degrees Celsius, one of the 9 planetary boundaries. So that's where we are. And unfortunately, if you take the latest IPCC and UNFCCC assessment of the journey we're following, even after the latest stocktake on the nationally determined contributions that were performed just before the New York Climate Week in September this year, we're following a pathway that takes us to 2.7 degrees Celsius by the end of this century. And let me just be very clear from the outset, that is, without any hesitation in science, a path to disaster. That's a path to disaster. We have no evidence whatsoever that we can support in a dignified and responsible way 8, soon to be 9 billion people in the world as we know it at anything above 2 degrees Celsius. Actually, we have not been at that point for the past 4 million years at the 2.7 degrees Celsius level. So this is why we're talking about urgency, that we really need to move this around very fast. Now, is this only me standing here saying this? Well, actually, no. The scientific community is now today has a very strong consensus here. This is the IPCC AR6 high-level conclusions, which I would just pick out what I would argue being the most important key take-home messages. And number one is that we now have unequivocal evidence that we are causing global warming. It is hitting human well-being today, but it's also threatening planetary health. Meaning that what we concluded in 2009 when we published the first planetary boundary paper, that we are putting the stability of the planet at risk, has now been established also as a scientific conclusion in the IPCC. We're putting the stability of the planet at risk. And then we have this really important finding in the IPCC that it won't be enough to phase out just fossil fuels to have a safe landing on climate. We have to keep the resilience of biodiversity and the whole nature system at a point where at least up to 50% of Earth's terrestrial ecosystems must be kept intact. Now, 50% is a very large number, but it's a very symbolic and important number right today because we've transformed in the order of 45, almost 50% of the land area on planet Earth to agriculture, infrastructure, and cities. So it means that we've come to a point where the scientifically defined safe land boundary is 0. We cannot expand agriculture anymore. We cannot expand ourselves into the intact nature that protects us with carbon stocks and zinc. That happens to be, by coincidence, the planetary boundary on land. So this is where we've reached, that we have so much support scientifically for this journey. We must become stewards of the planet. And let me just start this journey to take us to the planetary boundary science with also one additional very fundamental piece of scientific evidence that brought us to the framework. The first one was where I started, the pressures, the Anthropocene, which I've been talking about so far. The second part is what I'll be entering now, which is the paleoclimatic evidence of the stability of the Holocene. And the third part is tipping points. And then we put all this together, that's what brings us to the planetary boundary framework. Now, when it comes to the journey, one has to recognize that things are happening now at a pace we've never seen before. This is a wonderful little animation by the dear colleague Mark Maslin, who brought this forward as an animation of really good work by Osman et al. On paleoclimate. And this is temperature rise as we normally see the curve, as a quite linear line of temperature rise over the past 70 years. But if you just run this and just see what happens if you compare it to the last 500 years, you just see what an extraordinary hockey stick it is. Or we bring it back to 2,000 years, 3,000 years. Just look at the stability on planet Earth, and that the temperature rise that we see now is at 100 times faster than anything we've seen over the past 10,000 years. And this is the journey that we've seen ourselves, that we've experienced on planet Earth over the past 400,000 years. But let's just look from 200,000 years until today. Now, 200,000 years is a good point because we've been around on planet Earth as modern humans for roughly 200,000 years. At least that's our latest understanding. Now, what you see here is temperature variability on Earth. 200,000 years ago, we had an interglacial, warm, short 20,000 year period, the Eemian. And then, no, that's the one before the Eemian. We lived through one deep ice age, 100,000 years. We come into the Eemian 100,000 years ago. Then we enter the second ice age. We've existed on planet Earth as modern humans through 2 ice ages, one interglacial. And then we leave the last ice age some 16,000 years ago. We're hunters and gatherers. We're a few million people on Earth. We have very large environmental variability on the planet. We've actually coped through 2 ice ages. But we leave the last ice age and we enter the extraordinarily stable Holocene period. And as you see, roughly right at the beginning of the Holocene, we go through the most important revolution in human history, namely the Neolithic Revolution. We transition from hunters and gatherers to becoming farmers. We domesticate animals and plants. And off we go in the civilizational journey as we know it today, and we develop empires, civilizations, economies, differentiation of skills, innovation, and it takes us towards the modern world, the globalized world of today. What is so important here is that we're following a pathway, as you see, that takes us way outside of this entire range. Actually, if you look 3 million years back, through the entire Quaternary, the latest science, modeling work that we're running actually at the Potsdam Institute, indicates that we've never passed through 2 degrees Celsius. I call this today the corridor of life, that the warmest temperature on Earth, as we have been on planet Earth, on the planet that is biogeophysically similar to our planet today, because if you go beyond 3 million years, you have a completely different atmosphere, completely different composition of continents, a very completely different nitrogen, phosphorus, and carbon cycle, water cycle. So the last 3 million years is our only reference point, and within that time, we've, as far as we know today, never gone beyond 2 degrees Celsius, and deep ice age is in the order of -4 or 5 degrees Celsius. But the key is to zoom in on the Holocene, which is the latest epoch that has been the foundation for our civilizational journey. And here you have a much larger, detailed picture of this period. How we leave the last ice age 16,000 years ago, and we enter this extraordinarily stable Holocene phase. And this is a period with 14 degrees Celsius of average global mean surface temperature, plus minus 0.5. And this is increasingly proven to be the very foundational explanation why we shift from hunters and gatherers to domesticating animals and plants and becoming sedentary farmers. Namely, the stability of rainy seasons, spring, summer, autumn, winter, came predictably back every year. We knew that we could count on our rainfall, on our temperature, on our ecosystems, enabling us to move from hunters and gatherers to domesticating and cultivating plants. And that took us off into this differentiation journey that we have today, and now we're leaving this phase. Now, for the planetary boundary science, this is fundamental because it gives us a reference point. It shows us something that we have concluded as an entry point in the work, namely that the Holocene is the only state of the planet we know for certain can support humanity, at least the world as we know it. We've lived outside of the Holocene, but we've never taken responsibility for 8 to soon become 9 billion people. So that is very useful because we know a lot about the Holocene. We can measure against the Holocene as a reference point. Now, the reason why we believe that this is scientifically such a justified way of analyzing the state of the planet is that we have more and more evidence, shown on this screen here, that the reason why the planet has stayed in this stable state is not only that the solar radiative forcing has, during a period, been stable. Oh no, it's also, to a very large extent, thanks to the inbuilt resilience of the Earth system. And you have evidence of this both from the carbon cycle to the left and ocean heat to the right. So what you see here to the left is the now very well established Global Carbon Project, the annual update on the global carbon cycle. From 1850 until today, gigatons of carbon on the y-axis, so a billion tons of carbon in the carbon cycle. The hockey stick above the zero line is the classic one. It is emission of fossil fuel in gray and deforestation in orange. The 9 billion tons of carbon, roughly 40 billion tons of carbon dioxide that we emit. Is it all of this that has caused 1.2 degrees Celsius of global mean surface temperature rise so far? The answer is no. The ocean has taken up, in dark green, 25% of those emissions. Land ecosystems have taken up another 25%. So what you see here is that it's only the blue residual part that remains in the atmosphere that has caused the warming so far. The green part is what I would call today the largest subsidy to the world economy. This is the Earth system basically hiding half of our climate debt under the rug by applying its biogeochemical resilience. And you can be a kid looking at this graph and you'll see immediately, it seems like the more we punch the planet, the more she's protecting us. And that's absolutely right. Actually, the number is roughly 50% every year since we started burning fossil fuels 150, 250 years ago. Now, that is really humbling as a reminder of the enormous capacity of the complex, self-regulating Earth system. But unfortunately, we're seeing more and more evidence of cracks in this capacity. We have evidence that the Amazon, the Brazilian part of the Amazon, has already tipped over from being the planet's richest carbon sink to now being a carbon source. So the Amazon has already, in parts, flipped over and no longer is helping us. And we see more and more signs of pulses of carbon being released from permafrost, from temperate forests due to bark beetle outbreaks and different forest fires. And this is what is the biggest worry today, that we don't want to lose this resilience. And that's why we need a planetary boundary framework. To the right, you see the equivalent enormous subsidy to the world economy, namely heat uptake in the ocean. This phenomenal uptake of heat measured through thousands of Argo buoys across the entire ocean, 91%, this is an IPCC number, of the forcing, the energy imbalance caused by our fossil fuel burning is not in the atmosphere, it's in the ocean. It's not surprising that we get reinforced hurricanes and typhoons and storms and more evaporation, more loaded hydrological cycle, more moisture, and therefore storms like the one that we'll be experiencing here at night may be, through the weather attribution science, quite soon proven to have a significant footprint from our climate change caused by our fossil fuel burning. So the conclusion is that not only is the Holocene remarkably stable, it's also that what enables the planet to remain in this equilibrium state of the Holocene is determined to a very significant extent on the resilience and therefore the health or the sustainability, the stability of the different biogeochemical processes in the Earth system. But it's also important to recognize so that's one piece of the evidence into the planetary boundary science. So first one, Anthropocene, the pressures. Second one, the fact that the Holocene is a good reference point. It's proven to be a healthy, resilient state with capacities to buffer stress and to keep itself in an equilibrium state. The third piece of evidence is that we have understood increasingly that the Earth system has a set of climate tipping elements, big biophysical systems, that fulfill two criteria. One is that they contribute to regulate the stability of the climate system, but secondly, that they have multiple stable states separated by a tipping point, a threshold. Push them too far and they will flip over. And they flip over based on physics. It's really basic processes of feedbacks that change from a negative feedback, namely dampening capacity, to positive feedback, self-reinforcing capacities. These are well established, classic ones being an ice sheet, a permanent cold ice sheet is a permanent white surface reflecting 90% of incoming heat to space, and that albedo in itself is a self-cooling feedback. But if the system starts melting, it comes to a point where it becomes a liquid surface, which is darker, absorbing more heat, and you have a point where more than 50% of incoming heat is absorbed rather than reflected back, and that is a tipping point which becomes self-amplifying. We have been working very hard over the past 20 years, actually more or less in parallel with the planetary boundary science, to map tipping point systems. It started in 2008 with a paper by Tim Lenton et al. Tim, who's now at Exeter University, together with my predecessor at the Potsdam Institute, John Schellenhuber. And today, we have, since 1 year back, a significant update on the planetary boundary and the tipping point assessments across the climate system. And this has led to the conclusion that we have 16 large climate tipping element systems. And you see them on the chart here. I put the chart up because it shows they're across the entire planet. And the breakthrough, or the big step forward in this science, in this paper, is that we were able to put this color coding. For the first time, mapping off all the published research, we've been able to put uncertainty ranges on temperature and the most likely temperature at which these systems will cross their thresholds. And what I want you to point your focus on are the dark red systems, those that popped up now with the little chart here, which are the 5 systems that are likely to cross their tipping points, according to this assessment, at 1.5 degrees Celsius. And more scientifically, the assessment looks as follows. What you see here is the IPCC methodology on red embers. The red embers methodology basically provides the uncertainty range, but also in a color coding, the darker the red, the higher the confidence levels of a tipping point, in this case, occurring. And I want you, and you see the 16 systems on the x-axis, and I want to have your observations on these 5 systems to the further left, because the red line here is 1.5 degrees Celsius, and the ones furthest to the left are those that are likely to cross the thresholds at 1.5. And these include the Greenland ice sheet, the West Antarctic ice sheet, all tropical coral reef systems on planet Earth. Livelihoods to estimates vary, but in the order of 300 million people. The abrupt thawing of permafrost in the Arctic, and the Barents Sea ice. And just the 2 ice sheets here hold 10-meter sea level rise. And not that we cross 1.5 and you suddenly would have a flood of 10-meter sea level rise. Of course not. It would probably take 1,000, probably longer time before these massive ice sheets melt. The issue is it would be unstoppable. It would be crossing a tipping point where the feedbacks shift, so you would have basically an irreversible trend. We would be handing over to our children and all future generations an Earth system that slides in a direction that makes it less and less livable for humanity on Earth. So that is what this tells us. It's a very strong scientific warning signal to tell us that 1.5 degrees Celsius is not a target, it's not a goal, it's not something you negotiate with, it's a physical limit. It is something that we should really hold on to as much as we ever can, because go beyond it and we risk triggering these tipping points. There is an uncertainty range for sure, there's scientific debates still going on for sure, but this is the best assessment we have today. Now I want to point to you at one system that is very much in discussion right now, which is one of the 16 tipping elements, namely the Amazon rainforest. Our assessment, as you see, is that we're not so close to risking the Amazon rainforest. The temperature range for a tipping point is somewhere between 3 and 5 degrees Celsius. So, you know, climate-wise, a quite robust system. But this assessment has been criticized. I was just a few weeks back at the New York Climate Week, that's actually more than a month back, together with Carlos Nobres, the Brazilian leading climate and ecologist and probably the world's leading Amazon scientist, and he just tells me very frankly that you're wrong, you've got this assessment wrong. Because we come at this, he says, as ecologists. And when you look at that from the work that, for example, Tom Lovejoy, the late Tom Lovejoy, world leading ecologist, together with Carlos, they've been publishing on this, showing that the risk of tipping over the Amazon into a permanent savanna state, that's the multiple stable states in this case, is very likely going to occur at 20 to 25% deforestation of the system. So irrespective of climate, you can tip the whole Amazon system, according to the latest science, if you open up the forest too much. This is well understood today because the rainforest self-generates in the order of 40% of its own rainfall. So that's why it's called a rainforest. And this is thanks to the closed canopy and the moisture generated through the canopy and the root system. When you open up this forest too much, you get so much dry air flowing through that evaporation changes its dynamics and you get less convective rainfall. Now, the big question is, what combination of deforestation, ecological change, and climate change can risk the whole Amazon basin? And we don't have the answer. This is one of the scientific challenges we need to resolve very fast. But just sitting down with Carlos Nobres, his expert elicitation is that, well, if you say 3 to 5 on climate and we say 20 to 25 on deforestation, the very likely combination is probably somewhere around 1.5 on warming and 20% of deforestation. We are at 17% deforestation today and 1.2 on warming. So we're kind of moving fast towards that potential risk domain. So that's another argument why we really need to have a planetary boundary science framework that covers both biodiversity, land, water, and in this case climate, to understand the risks we're taking with the big biomes. Now, again, you may ask, who is saying this? Well, the temperature assessments is really in this David Armstrong McKay et al. Recent paper. It came 2 years after the IPCC. But this is actually table 4.1 in the AR6 Working Group 1 report listing the tipping element systems. So the IPCC also now recognizes that we have climate tipping elements. The key is that this column here is still unquantified. It has confidence levels, but no quantitative temperature levels. That's what we have now been able to contribute. Now, also what I want to remind you is that as science advances, the red thread so far over the past 25 years is that the more we learn, the more concern we have. The faster things seem to be changing, the higher are the risks. And this is one way of describing this. This is 5 IPCC assessments from the 3rd assessment 2001 until the 6th assessment. And it's again red embers, temperature, global mean surface temperature, of risks of causing irreversible changes in the Earth system. And the 3rd assessment basically placed the risk up at 6 degrees Celsius. In simple terms, no risk at all. I mean, nobody was suggesting then, nor today, that we would reach 6 degrees Celsius. I mean, that's kind of out of the charts entirely. So it was kind of zero risk, but just look at the trend line. The more we learn, the lower is the temperature range. So if you read the IPCC today, it will tell you that when you enter the range between 1.5 and 2, we have high risk of triggering irreversible changes in the Earth system. So we get a confirmation from the consensus across the entire climate science community. Now we have so much research that we've been picking into this kind of work on the risk assessment with regards to the Earth system, that permafrost is thawing faster than we had expected, that we have more and more worrying signs of potentially approaching a significant abrupt slowdown of the AMOC, the overturning of heat in the North Atlantic, that we have more and more signs of a tipping point in the Arctic, that we have really worrying signs from this year on extreme warming in coral reef systems in the southern part of the US. So all of this is kind of adding up to the evidence that we're really approaching points where we can, unfortunately, not exclude irreversible changes in the Earth system. And I want to close this before then coming to the planetary boundary part on just the final frontier that is not in the IPCC, but that we are seeing more and more papers on, which is cascade risks. And this was actually published in 2017 in a paper that I was part of together with Tim, where we summarize the latest understanding of how some of the tipping element systems, you see them on this chart, are interconnected. And I just want to tell you one story among these, which is now at our front of concern. And it's this one. So this is just another visualization. It was actually a visualization that we summarized in the so-called 10 New Insights in Climate Science, the 10 NICs, which we produce every year now to bring out the 10 most important scientific updates in science for the climate negotiators at the COP meeting. So we've just now finalized the 10 NICs for 2023. So I'm just a little marketing. If you want to Google 10 NICs, you'll find it. We do it now with the World Climate Research Program and the Earth League and Future Earth. So it's a really broad community effort. The story goes as follows. The Greenland ice sheet is melting very fast because of the amplified warming in the Arctic, the 3 degrees Celsius point, releasing cold fresh water into the North Atlantic, which slows down the AMOC. Because the AMOC, the whole overturning of heat in the North Atlantic, is a thermodynamic engine which operates on very well-established thermodynamic premises. Because you have warm, saline surface water flowing from the Southern Ocean up through the Gulf Stream, up to the southern tip of Greenland. This heavy, high-density saline water releases heat to the atmosphere, which kind of regulates quite a lot of weather over the United Kingdom and makes it possible to live where I come from, in Scandinavia. This heavy water sinks. And that pressure point is what drives the whole overturning, and it flows back at the bottom of the Atlantic, back to the Southern Ocean, and keeps this system cycling. The problem is that when the Greenland ice sheet releases massive amounts of fresh water, it dilutes the saline water, making it less dense, less heavy, it sinks slower, and so far the AMOC has slowed down 15%. Not a shutdown, but a slowdown, already at 1.2 degrees Celsius, 3 degrees Celsius on Greenland. The fear is that this would now continue and potentially slow down to a point of shutdown. That would be, I would argue, a disaster point. But that is very debated in the scientific community. However, there's evidence that when this slows down, it pushes the whole monsoon system further south, which can explain why we already today see more and more forest dieback and forest fires over the Amazon rainforest. Another tipping element system, as we discussed earlier. But not only that, when the whole AMOC slows down, you get, of course, more warm saline water stuck in the Southern Ocean. And that can potentially explain why the West Antarctic ice sheet is melting faster than expected. So there's more and more evidence to suggest that the Arctic may actually be a ground zero on planet Earth, connected via tipping elements all the way down to Antarctica, and that these are reinforcing each other. So that's another reason, I would argue, for precaution. And this is research that still is required to really understand this fully, but I just wanted to share that with you. Now, I also want to just touch on the following, just so it's really clear that we are now at 1.2 degrees Celsius. We're moving very rapidly to 1.5. We may touch 1.5 in the next few years, but most assessment shows that we will go through 1.5 somewhere around 2035. So that is, of course, very bad news, because I've now, I hope, quite strongly argued why we need to stay at 1.5. So the question is 1.5 then lost, or can we still hold it? I would argue that we can still hold it. The problem is that we can very likely not go straight to 1.5. Those set of scenarios, we assess, at least at the Potsdam Institute, it's unpublished, that the door is closed. So the IPCC scenarios, the so-called C1 scenarios that takes us direct to 1.5, is probably not possible anymore. So the only chance we have are the so-called C2 scenarios. Those hold 1.5 by the end of the century, but they have an overshoot period. So I think we have to, our assessment is, be ready for quite a jumpy next 20, 30 years, where we very likely are going through 1.5. We will have more extreme events. We are at risk of crossing tipping points before we, at best, can come back to 1.5 by the end of this century. And we have made assessments through these C1 and C2 scenarios. There are roughly 100 of them. We know that to hold them, we need to decarbonize the energy system. We need to go through the sustainability transition, as I mentioned earlier. Here you have them, those that can hold 1.5 at the end of this century. They have a roughly 0.1 to 0.3 degrees Celsius overshoot over something like 20, 30 years. Why would we come back at the end of the century? Well, again, it's a kind of a repeat that we need to decarbonize the energy system, so not load more carbon dioxide. And if we don't load more carbon dioxide, but keep the other planetary boundaries on the right side of the fence, biodiversity, fresh water, land, nitrogen, phosphorus, and the ocean, they will be able, as far as we understand, to keep on sequestering carbon. So we can basically cool the planet back to 1.5 if we can hold the other planetary boundaries. But that's what we at least conclude the best chance we have. And moreover, we don't even know what will happen during the overshoot period, what risks we take then in terms of potentially losing some of the major system stability. Will they cope with the 2-3 decades of overshoot? But that's where we are. Now then, to the planetary boundaries. So basically the story I've told so far is the pressures are high, Anthropocene. We have now evidence the Holocene is the state that we really have as our reference point, the desired planet. Tipping points are real. The tipping point science is what we use as an evidence base to quantify the safe space. And that is what has taken us to the planetary boundary framework. We asked the question, what are the biophysical systems and processes that scientifically have evidence of regulating the state of the planet? That's what's taken us to the 9 planetary boundary systems. And based on each one, we identify a control variable that is a good indicator for the state of these processes. And then we, through modeling, analytics, synthesizing science, and expert elicitation, have quantified the safe boundary levels to as far as possible, stay close to a Holocene-like state. Not back to the Holocene. There's no way to come back to a virgin Holocene state, but to have a Holocene-like state, namely an interglacial equilibrium state where we try to assess how much stress can the system tolerate without flipping out of that state. There's been a lot of progress over the past 5 years on the freshwater boundaries that for the first time takes in both green water, soil moisture, and blue water, runoff water. There's over 2,000 scientific papers being published on scrutinizing the framework and also suggesting improvements on the quantifications, which is what we've used to do the 3rd scientific update, which was published just before the New York Climate Week. And this is the assessment. So this was led by my dear colleague, Catherine Richardson, in a major effort over the past 3 years. We've been able to quantify all the 9 boundaries for the first time. So that's scientifically quite an important step forward. And as I think Matt referred to earlier, we assessed that 6, that's what you see here, 6 of the 9 boundaries are outside of the safe space. As you see, we're using the IPCC Red Embers methodology. They are, to a significant extent, in what we call the high-risk zone. The yellow zone is the uncertainty range in science. So you come into the darker red, you have a higher degree of scientific certainty of causing, of risking to deviate away from Holocene conditions. So this is a strong message that we are in a very dire situation in terms of the stability of the planet and the risks we're taking. It's not only climate, it's also the so-called biosphere boundaries, those that you have on the left-hand side here. Biodiversity, land, fresh water that in 2015 was assessed to be in the safe space, but now is assessed to be outside. It's from papers from other research groups that we brought into the synthesis, and then overloading of reactive nitrogen and phosphorus. We are still in the safe space we assess on atmospheric aerosol loading, air pollution, ocean acidification, and the stratospheric ozone layer, which is a success story because we were outside of the safe space in the 1980s when we were depleting the stratospheric ozone layer. The world listened to science, policy signed the Montreal Protocol in 1987, industry innovated, and we could move back to a pace where we today can conclude that the stratospheric ozone layer over the southern ocean, over the Antarctica, is actually shutting in again. So that's an example, a proof that we actually have been planetary stewards at least once. I wanted to show this graph. It's unpublished yet, it's in review, showing the journey from the 3 planetary boundary assessments. So in 2009, we could only quantify 6 of the 9 boundaries. We concluded that 3 of the boundaries were outside of the safe space. In 2015, we got 7 of the 9 boundaries quantified, but 4 outside of the space. And today we have the full integrated assessment. Now, I just want to say a few words on biodiversity, because in 2009, we only used species extinction as our indicator for biodiversity loss, which is only an indicator on genetic diversity, not very satisfactory in terms of the resilience and the functional diversity of ecosystems. In 2015, we added a control variable for functional diversity, and we used as an indicator mean species abundance, which is basically a good proxy indicator of the health of ecosystems. But now, in 2023, we've, I would argue, enriched this even further by adding something that we use very often, namely net primary production, the amount of biomass that you see in ecosystems, together with the extinction rate for species richness, to have a much more, let's say, measurable, down to the local level indicator for the full resilience of ecosystems. So the science of planetary boundaries is continuously evolving, but today we've come to a point where I would argue that we are really well established on the 9 boundaries, but also on being able to quantify them as a measure for the future. We're also for the first time doing modeling of interactions between boundaries. This is a very complex graph, so I won't go through it. Just to give you an indication of what we're doing here, we're basically having the climate boundary on the y-axis and the land boundary on the x-axis here. And already today, at the 350 ppm, even if we are at the edge of the safe operating space, we would have roughly 0.4 degrees Celsius of warming. But if we transgress the climate boundary and the land boundary, we would lose 200 gigatons of carbon, plus having an additional 2 degrees Celsius of warming. This is the kind of analysis that we're today able to prove the fact that you don't want to be outside of the land boundary and the climate boundary simultaneously. If you continue in that bad direction, you would actually be well beyond 3 degrees Celsius by the end of the century. While at the same time, if you're able to hold the land boundary within the safe space, sequestering 150 gigatons of carbon, you can hold off the 2 degrees Celsius boundary even if you touch the 450 threshold on climate. Just to show that how interconnected the Earth system is, and this is just looking at 2 boundaries, land and climate. Then I just want to, just as a kind of a second but last part, just share with you that the Planetary Boundary Framework has inspired the establishment of the Earth Commission. The Earth Commission is an attempt of having a broader scientific community to do kind of a broader assessment, a bit of like an IPCC for the planet assessment, and has done its first 3-year cycle and is now entering its second cycle. It brought in social sciences to also try and quantify just boundaries, not only safe boundaries, but also just boundaries. And the work started off by taking 5 of the 9 boundaries, so the Earth Commission could not do all the 9, but 5 boundaries in terms of safety and justice. And the justice part has been worked on in terms of maximum allowed significant harm. So at what point do you exceed acceptable levels of harm to people, and the significant harm defined as impacting millions of people, full communities, full sectors, or countries? And in doing so, not surprisingly, we end up in a situation where the outer ring here, the green lines, are the assessment. The green ones is when safe and just boundaries are equal. But just look at the red parts here, where safety and justice are different. So if you look at the climate boundary, the safe boundary level is based on the planetary boundary science and lands at 1.5 degrees Celsius, which we've been talking about so far. So that is set today as a safe scientific level beyond which we risk destabilizing the functioning, the biophysical function of the Earth system. But the social sciences tells us that the just boundary is the blue line, that already at 1 degree Celsius, we pass a point of unacceptable levels of significant harm. So this shrinks the space even further if we take people fully on board into the framework. And as you see, for many of the boundaries, safety and justice is assessed to be the same, but for air pollution, the AOD part there, and for nitrogen, the social science assessment shows that the just boundaries are actually tighter than the safe boundaries. And I think this is really important for us to understand that the planetary boundaries define the safety and stability of the planet for humanity, for sure. But if you want to really take a justice perspective, it is probably even more challenging than before. Then in the final part, just very quickly before terminating here, just say, what does all this imply in terms of transformation pathways? How do we come back within a safe space? Well, to begin with, it is really a transformation. I'll just put this on again to remind us that we're talking about 6-7% emission reductions per year. We're talking about an agricultural system that cannot longer expand into intact nature. It's been expanding with 1-2% per year over the past decades. It's really big changes that are close to what I would call social tipping points. We're talking about exponential solutions. We actually translated the climate boundary into the carbon law a few years back, because basically, if you want to really just decarbonize the energy system, it corresponds to cutting emissions by half every decade, which would take us along the pathway that IPCC has stipulated. So what we're seeing is that the journey ahead is very different to the journey that has taken us here. Incremental change is no longer an option. Now is the time to recognize the need for major nonlinear positive changes. Can we do this? Well, very likely we can. We have more and more empirical evidence that we are following some of these exponential curves. This is just one of them on solar voltaics and renewables. So you see our energy mix to the left there on coal, oil, gas, the total energy mix. You see renewables in that orange curve, which is ridiculously small, which is often why many, not least oil companies, state that, look here, renewables are great, but they will never form a significant part of the energy mix. The key is that it's doubling every 5.5 years. So renewable energy in the world has, for the past 15 years, doubled every 5.5 years. That's exponential. So if you just prolong that exponential curve, which we've done in these orange curves, you will find that by 2030, we will have potentially up to 50% of electricity from renewable energy, and following a very significant curve that by 2050, we would, if we would continue along that curve, have the entire energy mix potentially transition from fossil fuels to renewables. So it's quite interesting that we have more and more evidence that we can follow pathways that are nonlinear. This is a classic graph of showing how the International Energy Agency, over 10 years, actually 20 years' time, have completely misinterpreted the scenarios on renewable energy systems. How the black curve is what we have seen, the real observation in the world, and the color curves are the projections from each of the world, the best assessments on incremental change. So things are changing more rapidly than we thought. We've just done the 5th-year update of the Limits to Growth report, the so-called Earth for All report, which is together with economists and innovators around the world, running actually the World 3 model in an updated version along a number of transformation pathways, recognizing that we have a current path that is what we call a too little, too late. We're following an incremental pathway. So we're testing what would it take if we have a giant leap, real transformative changes across 5 big turnaround areas. And 2 of them is energy and food, the nonlinear transition away from fossil fuels and the transformation of the food system from source to sink in a regenerative agricultural revolution. But also much more equitable sharing of wealth, a gender revolution for female leadership across the world, and also looking at reform of low-income households in developed and developing countries. Plugging all this into the updated World 3 model, and I will of course not go through this in detail, it's just to tell you the story that we see major changes and decarbonizing energy systems and global greenhouse gas emissions, fertilizer use. We stabilize cropland across the world. Actually, we even stabilized population down to something like 8 billion people by the end of the century. Despite all this positive, despite plugging in the best knowledge we have on transforming the energy and food system, we still barely hold the planetary boundaries. It's just like almost coming in. Climate, nitrogen, phosphorus do not really come back into the safe space. And to me, that's a reminder that we're really in for a challenge. It's not utopian, it's not fantasy, but it is big. And we need to really be respectful to the fact that big things have to happen. And you may have remembered the Partha Gupta report that was commissioned by the UK government in the run-up to the Glasgow COP meeting, who took the best economic thinking we have today. I would argue this is the best report we still have of how to integrate economics with a stable planet, where he suggests that we need strong sustainability measures to guide economics and place the economy within planetary boundaries. That we now have to take that big step. It's not about growth or degrowth, it's really about an economy that operates within a stable Earth system, and quantify these fully. Is this utopia? Well, it's challenging, of course, but for example, we see that the Paris Agreement has a 1.5 degrees Celsius legally binding, unfortunately discussed as a target. It's a limit, but still, it's there on paper. The COP15 on biodiversity now has the Montreal Kunming decision of halting and reversing loss of biodiversity by 2030. That is a hard 0 point, a planetary boundary on nature. It is suggesting a nature-positive future of starting to regenerate nature by the end of this century, to rebuild that resilience that we need to be able to cope with the stress that's caused by planetary boundaries. So to leave you with, in the discussion here, I think this, in total, redefines sustainable development. It's now about prosperity and equity within a stable and resilient Earth system, within planetary boundaries. And we are now promising humanity, the world, everyone, that we will ramp up the planetary boundary science to a new level. At the New York Climate Week, we launched the Planetary Guardians, where we will be doing an annual update of the planetary boundary science, working with Earth observation actors to really serve much more science, much faster on the measurements of the planet, to just equivalent to a health check where we have a patient under chronic disease. You don't want to go to the doctor every 7th year and just measure temperature. You want to really analyze all the organs and do it much more rapidly to be able to really follow a pathway towards a cure. So that's what we're going to do. This health check will include a whole lot of work from modeling, tipping point assessments, Earth resilience analysis, Earth observation work. We're looking forward to having many partners in this. So it's an invite also to Edinburgh University. And this is quite exciting that we're stepping up to really provide the planetary health checks at a completely different scale than before. Because we are at this inflection point. We've made a lot of progress, but we're still pushing ourselves uphill. And we have many counterforces, unfortunately, still to struggle with. The 7 trillion subsidies every year for fossil fuels, for example. But there's no doubt in my mind that we're so close to this social tipping point where we start rolling irreversibly in the right direction. To me, the question is not whether we will phase out fossil fuels and if we will move towards a sustainable future. The question today is only one: will we be too late? That's the question. So we better move on and move very fast. And I know that I've spoken much too long. And we have an urgency, so I'll finish there and hand back to you, Fran. Thank you very much. Okay.
Well, thank you so much, Johan. I think we've all witnessed a tour de force, a masterclass in science communication, and I don't want to keep us really any longer until the panel session. So could I please invite Laura Young, and actually both of you, could Ian Boyd as well, come up to the stage. And I'll introduce them properly later. One thing I would like to say is we do have, people have been responding brilliantly to the Slido. We've got lots of questions to debate and chew over. But there is also, if people are shy of Slido and would prefer to ask a question at mic, there is a mic set up in the middle there. So we'll have a small pause between Slido questions for anyone who wants to come up to the mic. So, first of all, let me introduce you to the panel members you don't know. Laura Young is a hydronation scholar and busy as an environmental scientist, splitting her PhD between Dundee and Abertay University. She's also a well-known environmental campaigner, campaigning against single-use vapes, which I think is a fantastic thing to be doing. So welcome, Laura. Lovely to see you here. And Ian Boyd. Lovely to have you here as well. Thanks for joining us. For many years, Chief Scientific Advisor to the UK government on food and environment. Currently Joint Chair of the Environment Council for Scotland with the First Minister, and also Professor of Biology at St Andrews University. So welcome, everyone. I'm just going to move my chair slightly so I can see this question here. So, we have first question, how do we switch the debate? Oh, I forgot another one right at the very top. Doom messaging is well reported to be counterproductive and seems to cause stasis or recalcitrance to change. How do you suggest we get around this? Right, I think that is one for all the panelists because it's almost impossible to answer. But Johan, would you maybe like to start with that?
Yeah, so it's a really important question, and it's not that I disagree with it, but I would start by emphasizing that I'm absolutely convinced that we should stay with the truth and communicate the truth, and the truth is a dire diagnostic. And I'm actually convinced that people do not primarily end up in dismay or depression based on the diagnostic. What frustrates particularly the young people in the world is that diagnostic is not accompanied with credible leadership from policy, from business, from economics. So I think our task is really to ensure that for every time you raise the volume on the evidence of risk, you have to raise the volume on the story of solutions and keep that story integrated. So not leave people with only the negatives, but on the other hand, not back off from the negatives. I think we should actually be correctly representing the science. And again, remember back to that slide I showed on the IPCC. If there's anything one can criticize the IPCC for, is that it has been underestimating risks for 20 years. And that does not mean that it's underestimating the future, but it just supports the need for precaution. And I think that is an important element of this. But of course, we need also the positive stories. What can we do? And we have so many of those stories as well. And we've been bad at really communicating them.
Laura, what's your take on gloom and doom?
Do you know what? I think you're exactly right. I think we don't communicate this well enough, but we also don't do it in a positive way. So your final slide before the thank you had that graph up to 2050, and at 2050 it said, no carbon, no pandemics, no poverty. I want to get there. That sounds amazing. And I think it's our job to also, when we're talking about climate change, say, you know, we're not just doing this because it's a good thing and it's going to save the planet, but it's to create this beautiful, just environment. And, you know, a really kind of concrete example for here in Scotland, you know, we're navigating the sort of 15, 20-minute neighbourhood idea. And obviously that is something that is climate and health and supporting local economies, it's everything. If you're to listen to some of the way that people talk about it, it's as if they're going to put a big dome over you and say, you can't leave this 15-minute space, we're going to trap you in your local community, and it's going to be awful. And actually, that's not what it is. You know, it's about saying you could live in your local area. You don't need a car. You can get everything you need within 15 minutes. Your green space will be beautiful. Oh, that sounds amazing. And actually, I think it's our job to be communicating better and be training up scientists and communicators and people in the media to be talking about it in the way that it should be, rather than the way that we sometimes have, which has been a bit too doom and gloom, which has sort of fed a negative feedback loop.
Thanks, Laura. Ian, do you want to respond as well?
Yeah, I mean, first of all, Johan, thank you very much for a fantastic presentation. But yes, I think a lot of the messages can be very, very gloomy. I think we do have to be absolutely realistic. But in being realistic, I think we've got to construct the scenarios in such a way, as Johan actually has done, that it says to everybody, there are ways of dealing with this. So, you know, there's both a hard message and a way out. But you know, I think that Johan has been rather kind to us because he says there's a way out, but actually, you did say it is extraordinarily challenging. We're talking about transformations in a lot of the systems we have for living that we've never been through before. Some of them, you know, our energy systems we have transformed to some extent in the past, historically, but they've taken decades, if not centuries, to put in place. We've never transformed all those systems simultaneously at the same time and over such a short period of time. So we're right into unknown space here, and it is extraordinarily difficult. And frankly, if we're not frank and quite blunt about it, people are not going to respond, and we need to get people to respond as quickly as possible.
Mm-hmm. And we've got another question here, which is quite frank and blunt, and it's talking about limits to economic growth. Do we need them in order to stay within planetary boundaries? And Johan, I know that you had a look at, you revisited limits to growth in your work for Earth for All, the 50th anniversary of the first Limits to Growth report. How does limits to economic growth sit with you when thinking about planetary boundaries? It's a controversial question.
To begin with, I mean, the way we measure and define economic growth today is clearly not aligned with the future within safe planetary boundaries. So that I think is number one, that we need to internalize all the externalities. We need to put a proper price on all the damage we're making to the life support systems on Earth. So that's kind of one immediate stepping stone. That's why I like Partha Gupta's work so much, where he introduces a really strong economic methodology that is not contradictory to growth, but which internalizes all the functions also of natural capital. But secondly, one thing that is something that can be debated is that the planetary boundary framework itself is completely agnostic to growth or degrowth. It just sets the safe operating space, and then what happens inside that space is up to us. It just stay within the boundaries. And I believe that we cannot scare away the majorities that we need on this journey by saying degrowth is the only pathway to stay within the boundaries, because we have learned actually quite convincingly that will never get the big majorities of co-citizens to join in this journey. We see, for example, in Germany, which probably is the country in the world which has the highest percentage of population that vote green, act green, and really kind of are part of, let's say, the environmental movement, and they reach 20%. And in Sweden, it's 15%. And I don't know what it is in the UK, but I think that we represent a few of those countries in the world with the highest level of really aware green voters that would be willing to move along a degrowth pathway, potentially. And it seems to be a glass ceiling. You will never get the vast majority to join. And I think, therefore, Laura's point about, the journey has to be attractive. It has to be a story of a more modern, cooler, healthier, attractive, beautiful future that we simply want to join because it's so much more attractive. I mean, my definition of success is the moment when people go sustainable without even understanding that they're saving the planet. I mean, that's the moment when we really get ourselves moving. And I don't think that has to do so much with growth or degrowth. It has more to do with choices in life. And so I think we sometimes get stuck in that growth debate a bit unnecessarily. But one thing is for sure, as long as we talk about the green transition as a sacrifice story, we will fail. Mm-hmm. And somehow we have to place that into this economic development narrative.
And indeed, our next question kind of asks us to switch the debate to where the real impact lies. So switch it away from discussions about EVs and heat pumps and look at the really big zones of emissions, such as land use. And so, Ian, I know that you've been involved a lot with environment and food. What's your view on this discussion of putting our efforts where the big emissions are?
Well, we definitely need to do that. I think we spend quite a lot of our time dealing with the easy and small stuff and try to ignore some of the bigger stuff. I think a lot of that is going to require quite a lot of, if you like, social systemic change. In other words, we're going to have to live our lives differently. Going back to the previous question about economic growth, it's about how we define economic growth, actually. And, Laura's point about, this being about people being happy. Yeah. And it's about health and happiness at the end of the day. What do we want out of life is the fundamental question. And how do we get to that? I would posit that the model we have of economic growth today is not the one that actually delivers that. And I think we need to change that very, very substantially. And some of that will be about addressing things like food production, for example. Where do we get our food from? What kind of food do we eat? If anybody asks me if there's one thing that I could do to help save the planet, and it's relatively easy for me to do, what would it be? I would just say eat less meat. It's a really easy thing to do, and it would make a big difference. I'm not saying eat zero meat, I'm just saying eat a lot less meat. Mm-hmm. So, that would actually, it wouldn't solve all our problems, but it would get us a long way along part of the road. Mm. The other way I would articulate it is that we in Scotland, individually, on average, consume about 18 tonnes of materials a year. We need to get that to about 8 tonnes a year per individual in order to be a fair consumer of planetary resources. Now, actually, I would say that's actually achievable if we all individually put it in our minds that actually 50% of the time we're not going to be doing some of the things that we did before, or we're just going to make better decisions. And I think one of the things that we need to do is deliver the information to people so that they can make those better decisions, and we're not good at doing that at the moment, and we need to start doing that.
What about quick wins for you, or big wins for you, Laura? Where do you think they sit?
I don't know. I mean, for me, I think my brain, when it goes to this question, so often we get asked, what's the best electric car? What's the most sustainable car that I should buy? I think I want to wake up and not have to have a car. I want to be able to use public transport and my bike and have good walking spaces. It's not actually about what car we have. In the same way that people are often like, okay, climate activist, right? What are you going to tell me I can't have? What food am I not allowed to eat? And actually, I say, kind of eat what you want, but please just don't waste it. You know, one of the big things that we have around the globe is food waste. You know, a third of food that is produced and made globally is never eaten by anyone, and that, in a world where people go hungry, is just unacceptable. So I almost think with this question, it's about stepping back and not getting lost in what's the most sustainable diet, what's the most sustainable car. It's about stepping back and saying, how can we have a whole life approach to this? And I think it is about advertising it to people. When I started my PhD, I moved to Dundee and I had a house that I needed to do renovations to. So I'm sitting Googling what's the most sustainable power tools that I can buy, because I had to do, I think, a few pieces of drilling. And then I found out that in Dundee there's a tool library. So for £10 a year, I can pop in and get anything I need and rent it, and I don't need to buy anything. So I think it is about changing, you know, it is about consumption. But we don't even need to buy stuff. We can rent things, rent clothes, rent tools, rent gardening equipment, rent a gazebo if you want. And so I think it's almost changing your complete mindset to this and saying, I don't need to own everything. I don't need to have the fanciest high-tech, eco-friendly car. But actually it's about changing the way we even perceive just living a normal everyday life.
And some of the positives of that are you make friends while you do it, because you meet people when you go to the library. And
I also learned how to do drilling and wouldn't drill through a wire in my wall, which was also very helpful.
Well, I'm afraid we're running out of time, and we do need to move on so you guys can network and get a drink and everything. I do have one final question, which I'm using my privilege as chair to pose. And it stems from a discussion and some research that was done around Climate Week, which has been mentioned a lot in the lecture. And the research was done amongst G20 countries to try and find out what would be the unifying theme, what would be the unifying phrase to engage people to really move forward with great speed on sustainability and the direction we need to go to completely change our economy. And so these researchers went through 20 countries and they talked to lots of people. And the interesting thing is that the answer isn't something like leave it in the ground or save our seas or even outrage and optimism. The phrase that connected and unified everybody around engaging and moving on this space is the word love. And so with that, I would like to turn to each of you and ask you, if there was a bit more love in the world, how would that help your work have more impact? Ian, go for it.
You want me to take this one first? Okay. Well, I mean, I think it would make it a lot easier. There's absolutely no doubt about it. It depends to some extent whether it's conditional or unconditional. But I think the way I interpret that as a response is that what people completely understand is that we're all in this together. And we all have to, you know, do this as a team. You know, I think that if it's at the scale of the audience here, or all at the completely geopolitical scale, the global scale, you know, at all these scales, we need to be working together to respond to this crisis. Because actually, this is about a problem with the global commons. And it's about a tragedy that is developing in front of us, and we know that the only way of dealing with that is to work together in a concerted way with intent.
Thank you, and especially in a world where love and trust seems to be breaking down at the moment.
Absolutely.
So important. Laura, what's your thoughts on the love question?
I mean, I think when love was the words that you put to us, so I'm someone who has a Christian faith, and love your neighbour is something that I've kind of had swirling around my life since I went to Sunday school. And ultimately, you know, you first think love, well, that's a feeling. You know, I love people, I love my neighbours, I love the people in Dundee, I love the people in my family, my friends. But love isn't a feeling. Love should be an action. It should be, no, I love my friends and family, so I'm going to do things that make them happy, and I want to spend time with them. And I think in the context of climate, you know, when we talk about, so here in Scotland, and brace ourselves, we're about to have this storm, you know, I think about my neighbours in Dundee, in my tenement flat, who, you know, we don't have great double glazing and we don't have insulation. So we're going to be getting mold coming through the walls. We're going to be having leaks I had a leak in my ceiling last week with the rain. And I love my neighbours, and I don't want them living in somewhere that doesn't have dignity. So I want to act with that love to make a change. And so I think for me, I want people to love everybody in the world, is that really cosy feeling, and love the world, but not just feel it, actually do it and want to go out and make that change so that people can live in dignity, so that people aren't pushed to the margins because they live in a coastal community that has sea level rise, or the coral reefs are at risk, or it's ultimate heat. So I think for me, it's if more people had that love into action, that would be a fantastic outcome.
Active love. Johan, how about you? What does love mean for your work?
Yeah, it's a difficult question, but I mean, of course, if love means peace, I think that is something really significant for the sustainability transformation. On the other hand, we cannot love everyone, and I think we will never reach a point where we have, let's say, full scale of love across the entire world. But one thing I think we underestimate is that no one wakes up in the morning deliberately trying to destroy the planet. I think we're caught in a system that simply brings us to this point of not really understanding of all the implications of our consumption and choices in life, and how we go about our economies and businesses and life in general. So I think we need to reconnect to the planet, and I think that is a piece of love that could be universal, the love for planet Earth. I mean, as far as we know, there's no other planet out there, so even though we have a few crazy guys wanting to find life on other planets, but I think we need to reconnect with planet Earth and have a message, a story of love for planet Earth. And Colin and I talked about this morning of how important belief systems and religious leaders can be in helping us also in the narrative of what does it mean to reconnect with creation. And I think that I think everyone can love. But then finally, just to say that there's a very operational part of love also, which is that, you know, a challenge we have is that we have an all-time low of trust in the world today. And trust has a lot to do with respect, and respect has a lot to do with love. And I think what we need is collective action. The only way to solve this is that we trust each other, and that we start really acting as global citizens, because we sit here in Edinburgh, but we also depend on a stable green and ice sheet and that the Amazon rainforest is intact. But the only way to secure that is we can respect those who are managing those systems somewhere else on planet Earth. And that requires a really high degree of respect and trust, which you could call love in a way. So I think it's not surprising that came out in that opinion poll, actually. I think that's quite interesting.
Yeah, I think it's super interesting. So it's true we can't love all people, but it seems that amongst the panel we do agree that we can love the planet Earth universally, actively and unconditionally. So thank you very much, everybody. Please applaud the panel. We're all staying here.
So, thank you, Fran, and it's my pleasure to offer a vote of thanks for this evening, and I hope you've really enjoyed it. I have. It's been deeply insightful for me and really inspiring. To the Macaulay Development Trust and the planning committees for their unfailing and creative work given freely to make this happen today, to the Hutton Comms team and to Pinson Masons for all their great support in today's roundtable event, to the University of Edinburgh and the helpers here for the use of this excellent and beautiful venue. It really is wonderful. Thank you all. Also to our exhibitors, MDT fellows and students, and of course to this audience here for coming tonight, and all those who've asked questions. Thank you very much indeed. To Fran and our panel, thank you again. A really interesting conversation, and who thought we would end up talking about love. I'd like to make a special tribute, actually, to Fran as chair of the Macaulay Development Trust. Fran, your leadership of the Macaulay Development Trust over the last few years has been absolutely fantastic, and has been of great benefit to the James Hutton Institute, and I just want to note that. I'd also like to thank Miss McCallan and Matt Williams in particular for the excellent and encouraging opening remarks and the ambition around the policies in the Scottish Government. And finally, to our guest lecturer, Johan. Huge appreciation and thank you, Johan. We know how precious your time is, and we feel very privileged to have had you here tonight. At a time such as this, which can feel so urgent, pressing, and confusing, we need leaders and communicators who remain calm, rational, and optimistic. So we've been truly inspired by the strength of your evidence and the future vision for a better world. I'd like to go back to Senator John Kerry. When he was here in Edinburgh recently, he also said, "The Enlightenment transformed thinking to win acceptance of the principle that science-based evidence, not vested power promulgating in its own tradition, is the foundation of the laws of the universe." I hope the lecture today has strengthened this sentiment and that statement. However, it's also important to recognise that it was during the Scottish Enlightenment that Scotland led the way into the fossil fuel era. And we think it's very important that we and the community of interest gathered here tonight try and lead us into a new era in the future. So, dear guests, I hope you leave here tonight with renewed hope, greater awareness, and new ideas for how to help future generations succeed. So please join me again in thanking all the speakers and those who've contributed to a successful evening. So, by way of thanks, I've got a few gifts here, and for each of the panellists, we have the very latest book by James Hutton, The Genius of Time, and if the author is sitting in the panel, in the audience here, he'll even sign it for you. For Johan, we also have a Scottish quaich. And a Scottish quaich is a drinking cup, and a symbol of partnership and friendship. So I'd like to present that to you.
Oh, thanks a lot.
Yeah. And lastly, you've probably become aware that Johan is a bit of a rock star in terms of climate science and climate change. And of course, the James Hutton was the original rock star. So I've actually got a T-shirt for you, Johan.
That's good. That's wonderful.
So we're at a close, but we're not finished. We have a reception with some food and refreshments down below. If you've registered for this and you're wearing a lanyard such as this, you're very welcome to join us and continue the conversations with the panellists and with each other. We have another space for 50 people who don't have lanyards on a first-come, first-served basis. So please do feel encouraged, do come and join us. It'd be wonderful to see you. There's lots more to see down there in the way of exhibits that I think will be of interest. So thank you again, and invite you to come downstairs to the reception, or if you're unable to come to that, you can leave from this floor, and a very safe onward journey. Thank you once again.